Welcome to MongoDB Essentials. Understand the basics of MongoDB. My name is Patrick, and I will be your instructor. In this course, I will walk you through the most important parts of MongoDB to get you quickly up and running. We'll discuss what NoSQL means and what are the pros and cons of using a non-relational database like MongoDB. After installing MongoDB, we'll dive into the shell and explore the most used command line functions in order to create, read, and update our Mongo documents. Then, we'll explore the different types of data we can store within our documents. We'll finish up by discussing the various query operators we can use to drill down and extract the documents that we're looking for. This is a beginner level course and an introduction to the world of MongoDB and NoSQL databases. Before getting started with this course, you should already know how to access your command prompt and already have installed a text editor such as Sublime Text or WebStorm. Lectures will be a combination of PowerPoint slides and examples that you can execute within your terminal window. Introduction to MongoDB. Hello. In the first few videos, we'll discuss the basics of MongoDB and introduce important concepts. We'll start with a discussion on what MongoDB is and how it fits in with the node landscape. Next, we'll see how you can install MongoDB on your machine. After that, we'll take a look into a few of the terminal commands to start MongoDB and access database collections. There's a few key points to remember when dealing with MongoDB. Number one, instead of using tables as you would in SQL, we use documents. And these documents are structured in BSON, which is almost identical to the commonly used web language JSON. Number two, it is a NoSQL or non-relational database. The main difference when compared to a SQL database is you're not able to use joins to connect your database tables. Instead, however, we can use references to link between our various documents. What are the advantages of using a non-relational database like MongoDB over a traditionally structured database? Some of the key advantages are: it's quick and easy to make iterations on your schema. When compared to relational databases, NoSQL is more scalable and provides better performance. And this is according to MongoDB.com. It's object-oriented, so the administration of adding, reading, and writing looks very similar to JavaScript code. Agile development is the ability to quickly iterate. Per the MongoDB website, the NoSQL database accommodates large volumes of rapidly changing structured, semi-structured, and unstructured data. And that basically means that you're able to add to your schema as needs change. An example of this is if you've already created a schema named user with a first and last name, and later you realize that you also want to add a phone number. Now you can simply update your schema to include this new key value. For more information on the differences between SQL and NoSQL databases, you can visit the link below. We'll be using documents and collections throughout this course, so it's important that you have a clear understanding of what the differences are. A document is defined as a record in a MongoDB collection and the basic unit of data in MongoDB. Documents look like JSON objects, but they exist as BSON. Here's an example of a document that stores some data for an article. You can tell that it's stored using BSON because there's quotation marks around both the key and value pairs. A collection is a grouping of MongoDB documents. Typically, all documents in a collection have a similar or related purpose. And here is an example of a collection. In this collection, we're storing 2 documents, and each document has some data about an article. You can download MongoDB by going to their website, going over to the download section, and choosing to download whatever instance suits your system. I'm using Windows 8, so I would download the 64-bit. And just one thing, if you do run into any troubles with installation, you want to make sure that you have a bin folder created wherever MongoDB was installed. So for me, MongoDB was installed in my program files, then MongoDB, then server. So C drive, program files, MongoDB, server, 3.2, and there should be a bin folder created. This will hold the executables like mongo that you need. Once you have that all set up, you'll want to open up a couple of command prompts. I usually have one open and then type start cmd.exe to open up another one. In order to get the local instance of MongoDB running, you'll want to use the command mongod, that's M-O-N-G-O-D. And you may need to navigate into the bin folder I showed you earlier, and then from there you can type mongod. And what this will do is it will give us access to our Mongo shell. So in order to use our shell or run any applications locally that are using MongoDB, we need to have mongod running. Now, in another terminal, I'm able to use the term mongo, that's M-O-N-G-O, to open up the MongoDB shell. And now I want to show you a few of the most common commands when using the shell. So the first one is showdbs. Showdbs will give us a list of all the databases that have been created. So as you can see, I have a bunch of these. I can choose to use any one of these databases by using the use flag, and I can also create a new database by using this use flag and then naming it whatever I want. I've already created a database instance called test, so let's go ahead and use that one. So now it's saying switched over to DB test. So now I want to see what document collections I've created within this test database. System.indexes gets created automatically. All these others are collections that I've created either within the shell or by creating a schema. The schema, which we'll talk a lot about, is a representation of the collection, and it will constitute key value pairs. A command that I can use to look into one of these collections is the find method. db dot, then the name of the collection that I want to look at. We'll start with things.find. We can see that there is one document in this collection. This document has an underscore ID key whose value is set to an object ID. This field gets automatically generated every time a new document is created. And this document also includes one object with the name of Will. We use JSON to define the objects in our database, which then gets converted into something called bson seen here. And the only difference between these two in code is that bson has quotation marks surrounding both the key and value pairs of our objects. We can easily manage our data using JSON. which stands for JavaScript Object Notation. JSON is a very common language we use for passing around data from the view to the server and back. Let's create a new JSON object with two key value pairs of first name Bill and last name Cruz. And that's really all that there is to it. Now, let's open up our shell and learn a new command. As you saw earlier, we can use the find method to print out all of the documents that we have added to our collection. And this prints out a string of everything that we have in there. But it is pretty hard to read, especially if you have a lot of documents. One way to fix this is that we can chain a command called pretty, which will then display all of our documents in a much easier to read format. In this video, we'll discuss some of the useful commands for adding, modifying, and finding records within our collections. We'll be using the Mongoose shell to execute these commands. It's a good idea to get to know these shell commands before diving into Node, because the code that we write will end up using a lot of these methods and look very similar. We're only going to be using some of the methods that are found in the MongoDB document reference. You can see all of them located right here. We'll be looking at the ones that we use the most, such as update, insert, find, and remove. So I'm going to start as we did previously by opening up two command prompts. One of them will have mongod running in order for me to open up our Mongo shell. Let's start off by creating a new database, and we can do that by using the use command. So we'll say use example. Whenever we're using our Mongo shell to execute commands and hook up to any of our databases, we always use the prefix db dot. So the first thing that I want to do is add a new collection to my example database and name it cars. And I can do that by using the create collection command. So we'll say db dot create collection, and then we'll pass in cars as the name of our first collection, and we get an OK response. Now I can use the command show collections, and you can see that I've added a new collection called cars. I've also added a couple other collections already in here called car and things. For a lot of these examples, I'm going to start using a text file and then copy over into the terminal command what I'm writing here. So the first thing that I want to do is add a new document into our cars collection. And to do that, I can simply use the insert method. Now I can define whatever key value pairs that I want to insert into this document. I'll give my new document a name of Honda, a make of Accord, and a year of 2010. A couple points that I want to make. Number one, we can include a semicolon at the end of this, or not. It's optional. It's also optional to use single or double quotation marks, so we could use the single ones or the double ones. And it's also optional to use quotation marks around surrounding the key, so we can use quotation marks or not. And the reason is because everything that we're submitting is in the form of JSON. So this is a JSON object. But once we actually submit it to our database, it gets converted into BSON. So I'm going to copy this over into our terminal. And I'm going to add it. And as you can see, I get a right result and inserted one. So now it should show up in our database. In order to print or find the document that we just created, I used the find method and then I chained it to pretty. So pretty just gives us a better formatting for displaying the document that we already have added. Now I'm going to show you how to update this document. So say I wanted to change any of these key values to something different. I wanted to change the name to something else, the make or the year. We can easily do that using the update method. So I can say update.car, or excuse me, db.car.update. The first parameter will be what document that I want to modify. And in this instance, I want to modify the Honda. So now MongoDB will look for a car collection with the name of Honda. And in order to modify that, I have to use a set parameter. So I can say set. And now I'm able to change whatever it is that I want on the document. So I could specify that I wanted to change the make, the year, or the name. In this instance, I want to change the name from Honda to Ford. I'm going to copy this over into my terminal. Okay, and it looks like we got a success message. The right result says that we found the match and that we modified it. So now I can use my db.car.find.pretty. And we can see that the name has changed from Honda to Ford. Now I want to show you an example of how we're able to update our document by adding something to it. So we have a document of cars, and now I want to add to this document a key value pair for the transmission being automatic or manual. And all I need to do in order to add something new to my document is by using the upsert key. So I still want to update, and instead of this being a Honda, remember we changed it to the name Ford. So now we're going to look for a Ford, and at the end of this we're going to add a third parameter called upsert, and this is basically an optional parameter that we can pass in when we're finding or modifying documents. And it takes a boolean. The default is false, but we can set it to true. And we're going to still use our set command, but we're just going to put in what it is that is new that we want to add to our document. And we're going to add transmission, and we're going to make it automatic. So now I'm going to copy this over. Okay, and we get our result of matched and modified. So now if I take a look at our modified document, we can see that a new key value pair of transmission automatic has been added. One other method that I want to show you in this video is the remove method. So to remove a document from a collection is pretty easy. We can just say db the collection that we want to look into and then remove. If we pass in an empty object, it will remove all of the documents from the collection. Alternatively, we can pass in what it is that we want to remove. So I can pass in name Ford, and it will remove the documents with the name equaling Ford. And we have one that it's found and it's removed. So I could say db.car.find, and I get nothing back. So it's removed all those documents. Let's take a moment to discuss an interesting feature of the Mongo shell. The Mongo shell works as a JavaScript interpreter. So in the same way that you can write JavaScript code to a Chrome console, you can write code to your Mongo shell. So to show you an example of how this works, I'm going to create a for loop and insert 10 documents into our things collection. First we're setting I to 0, then we're incrementing until we get to 10. So x should be 0 to 9, and each time x increments, we create a new document setting x equal to the incrementer. And now, after using our find method to look into the collection, we get the expected result of 10 documents, each being made with a value of x from 0 to 9. In the previous video, we looked at how to create collections and add documents using the $upsert method. In this video, we're going to discuss what types of data we can add to our database. We've already introduced the concepts of what a schema and a collection are. You can think of them as essentially being equal, in so much as the schema forms a representation or a model in code of the data that gets stored into our collection. Let's now take a look at the different types of data that can get stored. There are 6 main data types: string, number, date, array, boolean, and object ID. This graph shows you what a typical key value assignment is when working with each type of data. And then below that, what a typical JSON response object would look like. So string, number, and date are pretty self-explanatory. When using an array, we can define it with the array reserved word or with brackets. Booleans can be set to either true or false, and object ID refers to another collection or schema. In a future example, I will show you how we can have a book schema that references an author schema using the type object ID. There's also 2 other data types that we won't be using in this course. They are buffer and mixed data. Buffer is used to store things like images, video, and audio. Mixed type allows you to store different types based on what you pass into it. So you might want to store, in certain instances, strings, and in other instances, arrays. In this video, we're going to see different ways that we can query our database to get back what we're looking for. We'll be using the find method and passing in different parameters to retrieve the data. Next, we'll see how to sort the items we get back and how to limit the results. Let's continue using our example database that we created. So I'll say use example. I'm going to create a new collection in this database called student. So db.create collection, passing in student. Now I'm going to add a bunch of documents to this collection using the insert method that we did in video number 2. So here's my text file, and this will be available to you. So I'm just going to copy over the student inserts. So I can copy these over, and it'll say right result equals 1, but I should still have these 4 documents in my collection. I'll say db.student.find and then .pretty, and we can see that we've added these 4 documents to our student collection. So at this point, we'll take a look at different ways that we can query our collection to grab out certain things that we might be looking for. And in this collection of student, we basically added a name, whether or not they're an undergrad, the number of units that they're taking, and an array of classes that our student is taking as well. So the first query example you've already seen, and that was find. db.student.find. Usually, when we're trying to get back all of the documents within a collection, we'll pass in an empty object. So in future examples, when we're actually building up apps, you'll see something very similar to this when we're trying to retrieve all the documents from our database with nothing else specified. Say we want to find one specific student. We can pass in a query that looks like this. And this could of course reference anything. It could reference the name, the undergrad, the units, or the classes. It will find all of those with the reference that we're looking for, in this case Rachel, and it will respond with those documents. And you can see that it pulled out the one document with the name of Rachel. We can also chain the .pretty method in order to make this look more readable. One way to filter the documents that we're looking for is to use the $GT or $LT, and those stand for greater than or less than. So we could use something like this, in which case we're going to filter for units that are greater than 6. So we should get back only two documents, the 12 and the 9. And we should not retrieve these two because they are less than 6 or equal to 6. And we're looking for all those documents that are greater than 6. So we can copy that over, and you can see that we have two results. And we can clean this up by chaining pretty, and you can see again we have only those two results. Alternatively, we can filter for less than. So if we say less than, we'll say 7 units, we should get back the two documents that have 6 units and 3 units. And you can see we're getting back the two documents that have units of less than 7. Kevin's units are 3 and Rachel's units are 6. Another helpful query method is the in command. So in this example, we're looking within the classes field, and we want to pull out all those students that are enrolled in history. So using the in, we always have to specify an array. So we could say history and geography, for example, and this would be an array. But in this instance, we're just going to pull out all the students that are enrolled in a history class. Okay, and again, we find two students, Jane and Rachel, who are enrolled in history classes. So in can be a pretty useful command for filtering out your documents to find specifically what you're looking for. Now we'll take a look at how we can sort and limit the results of our queries. So when we're sorting, we typically assign either a 1 or a -1 to whatever it is that we're trying to sort. So in this instance, we're looking for students enrolled in history, and then we're sorting by ascending, and we're filtering by the number of units. So whichever student is enrolled in fewer units should appear at the top of the data that we get back. And when we submit this query, we get back first Rachel, who's enrolled in 6 units, and then Jane, who is enrolled in 12 units. So it was able to pull out those students, again enrolled in history, and then sort based on the number of units that they're taking. And we can clean this up a little bit so you can see it better by using the .pretty command. Again, Rachel is first and Jane is second. So as mentioned, we typically when sorting will either use 1 or -1. So 1 would be ascending and -1 would be descending. So in this case, if I put -1, then we should see Jane at the top. And we do. When we're using sort, it will either sort numerically or alphabetically. So in this case, we're sorting numerically. If instead we wanted to sort alphabetically, we would be sorting a string. And since we're using 1 as our method to sort, we'd be sorting in a descending manner. So those with the name closer to A will appear first, and those with the names closer to Z will appear towards the bottom. Okay, and that is what we get back. First Jane, then Joe, then Kevin, then Rachel. So I was able to look through all of the documents, extract those, and then sort them in a descending order. And finally, we always have the option to limit the number of results that we get back. And we can easily pass in just a number so that after retrieving all those documents according to whatever specificity that we've indicated, we can then say, now only give me the first 2 that you get back. So again, you can see how we've limited this to the first 2 results sorted by name. So we get back Jane first and then Joe. Now these are just the most common and useful commands that we tend to see used within MongoDB. There's more, and you can find those in the query documents of MongoDB. So we've used in, we use less than. You can also use or conditions and conditions.